uploaded on the Padlet. So you're going to have a look on here. After the slide finish, then I will go through the project brief so that the students can have some clear understanding on how to proceed with the group project. One of you already messaged me today. Thank you to, I think it's Imran, I think. So if you are on the Google Meet, then please make sure to remind me about the project brief. Right, so slideshow. Okay, the slide for this one has been uploaded on the Padlet. Okay, so an extension on the refrigeration topic. The purpose of the slide is just to provide the student with a brief overview on the so-called industrial refrigerations. And you will begin your internship, inshallah, next year, if I'm not mistaken. Okay, so when you embark on your internship program, so you can select either you want to conduct in which area. Okay, is it purely mechanical, or is it going to be a flavor on energy side and so on? And some of you may have the opportunity to conduct your industrial training or attachment with industry related to, for example, refrigerations or energy storage system and or equivalent. Okay, so industrial refrigeration, although the basic fundamental concept is similar with the, we call it household refrigeration system, like our refrigerator and freezer systems. Okay, so they'll be using the same concept, and if you are able to get the opportunity to be attached with companies or industries that involve in the industrial process, then you may have the experience and the exposure on this. Okay. In the previous years, long time ago, usually students for this topic, zaman dahulu, pelajar bertemu dua akan apa, will conduct industrial visits. Either you go to the power plant or you go to any industries related to refrigeration or related to cooling tower system process and so on. Okay. And since last year, we are still facing with the pandemic challenge. So now it's down to the student to really search for information on how the industries is using the theories from thermodynamics and how we can apply the theories to our day-to-day needs. So when we want to classify a refrigerant, okay, bahan penyujuk, so there are two determinants. First, it's on the ozone depletion potential. There is a value ranges from 0, which is doesn't have any impact on the ozone layer, and 1, which is categorized as the most harmful for the ozone layer. And the second determinant or parameter is what we call as the global warming potential. It also has a range from 0 until several thousands. The higher the GWP value, the more harmful the refrigerant is for the global warming. So those are the two scales that the industries are using to characterize or to, we call it, characterize, categorize, and classify any new refrigerants in the market. What will be the ODP value, and what is also the GWP values. Okay, so for ODP values, it's either between 0 to 1. 1 means that the refrigerant is harmful for the ozone layer. 0 means there is no impact to the ozone layer. And the next determinant or the next parameter is the value of GWP, global warming potential. So it started from 0 until a few thousands range. Okay, another way to classify the refrigerant is based on what are the pressures at different operating temperature. Okay, if you can see here, we have the R134A, R717, R744. Okay, sorry. R410A in liquid and vapor form. So you can observe that at different working temperature, so at a specific working temperature, so each of these working fluid or refrigerant will be having different pressure. Okay, for example, at 0 degrees Celsius, R134A requires 2.93 bar, and the R744, the pressure is around 34.85 bar. Another classification for the refrigerant is what we call as the natural. Is it synthetic buatan ataupun ni natural ni asli lah, ataupun secara okay, kata BE natural. Can you actually outsource or obtain the refrigerants through natural means? So the organic refrigerants, okay, based on the hydrocarbon compound, okay, organic refrigerant is what we call as the or HC refrigerant. We call this as a natural refrigerant because they occur in the Earth's material cycle. So once you actually dealing or manipulating the hydrocarbon compounds, maybe through the natural gas production or through the oil refineries, you can obtain this hydrocarbon-based refrigerant. And hydrocarbon is actually the elementary compound of hydrogen and carbon, and anything that related to the crude oil processing, you can actually obtain this. So this is what we call as organic. Organic means that you obtain it from the natural means, from the mineral available from the earth itself. It's not a synthetic. It's not something that you made up through a specific chemical processing, or we call it a lab process. Propane, isobutane, propylene are the example of the hydrocarbon refrigerants. So they have their own code. So once you start working as engineers, especially in the refrigeration industries, you'll be working with a different type of refrigerant. So for each type of refrigerant, they have their own database, or we call it the properties. So the theories remain the same. So you need to refer exactly to what the data provides, and then you need to do the calculation based on each database for each type of refrigerant. Okay. And some hydrocarbon refrigerant contains blending from ethane, or we call it butane. The hydrocarbon-based refrigerant is being classified as having the excellent thermodynamic properties, and which is this respect they are as good as better than to the HCF or the HCFC refrigerant in most applications. However, they are highly flammable. Okay. Also, they have zero and negligible GWP. Okay. When you classify based on the two parameters, based on the call it ozone depletion potential, okay, and based on the GWP. So on the GWP scale, hydrocarbon refrigerant is considered to have zero value. Nevertheless, they are flammable. Senang terbakar sebab apa? Sebab dia ada hydrocarbon elements for the refrigerant. If the refrigerant is still obtained without the presence of hydrogen and carbon, so the refrigerant is termed as the inorganic. Bermaksud di sini tiada kehadiran carbon dan juga hydrogen. Okay. Inorganic refrigerant consists of inorganic compounds, meaning there are no carbon and hydrogen elements. Okay. For example, the ammonia refrigerant R717, the ODP is 0 and the GWP value is also 0. The challenge of utilizing the ammonia refrigerant, not only is a flammable gas, but two additional challenges are is toxic and has a very distinct pungent odor, bau yang kuat dan menyengat. Although the the smell pollution, if you can say that. It's very dangerous to those around, to those actually working with the ammonia refrigerant. The good side of it can help users to detect if there is any leakage in the system. Initial energy is 50 times higher than natural gas and will not burn without a supporting flame. So we need to handle carefully the ammonia refrigerant, and at the same time try to always be on alert on the prevention on the leakage, and also try to detect if the good thing of having the strong pungent odor is that you can detect if there any leakage in the system. The next type of inorganic refrigerant is the carbon dioxide. ODP is 0 and very low GWP value, which is around 1. And you can use it for industrial, commercial, and also for mobile air conditioning system. The differences between CO2 refrigerant and the other type of refrigerant is because the requirement of the high pressure for it to operate effectively. And when we say high pressure, means that the pump and everything, that the compressor and so on will need to be able to provide the required pressure for the system to operate. Okay, and then we have what we call the synthetic. Synthetic ni campuran atau pembuatan lah. Yang tadi tu ialah yang terhasil ataupun wujud dan ataupun boleh dicari, dijumpai, diproses daripada sumber yang sedia ada. When we say the natural resources is what are available once you start dealing with petroleum-based substance or anything related to petroleum. We talk with something which is related to the fossil-based system, and petroleum-based equivalents to the presence of hydrogen and carbon. So those are what we call as organic and inorganic. So the origin are from those type of source. Okay, but once you start to play around chemically all these different element and gases or refrigerants, then we term that as a synthetic refrigerants. Okay, so bahan penyejuk buatan. Okay. CFC is the one of the most famous example, and then followed by the hydrochlorofluorocarbon HCFCs, and then we also have the hydrofluorocarbon refrigerants. So each of these refrigerants, starting from the natural, the organic, inorganic, they have a different code and so on. Okay, R744, R717. Okay, for this one R290. R stands for the refrigerant. Same if you're dealing with CFC until HFC, they also carry the same letter, which is the R as a refrigerant, but different coding. Okay. Chlorofluorocarbon, as the name suggests, contains carbon, fluorine, and chlorine. The second one also only carbon, only the 3 element. Additionally, it contains the hydrogen element. Okay, the index for the HCFC is between 0.05 to 0.52. That's why HCFCs are considered as the greenhouse gases, because the ozone depletion potential has a value. Yang sebelum ni dia tak ada nilai. ODP nilai dia adalah kosong, tapi untuk yang ni dia ada nilai. Okay, so different type of refrigerant carry different ODP and GWP values. Okay. Application of refrigerant. So I think this one you just can browse through. Usually for the food and beverages. Okay. Again, then fish, poultry, meat, dairy milk, fruit and vegetables. If you can see on here, chilling, freezing, cold storage. Okay. Chilling, freezing, cold storage. Chiller, freezer dengan penjujukan cold storage. You look on the required working temperature. The chilling process requires around 0 to 2 degrees Celsius. Okay. Freezing or freezer around minus 25 degrees Celsius. For cold storage, it's around correct, either chill or frozen. So between those two temperature. So that is the requirement if you're working with fish. So in this food and beverage industries, so this is requirement. So the engineers or the call it the refrigeration system designer, they need to work with the industries. Okay, if you are dealing with poultry, then this is your range of operation. So if this is the range of operation, what will be the required mechanical system, the compressor, the throttling device, the condenser, and so on. So what evaporator, and then what will be the best type of refrigerant to be used. So these are the indicators. Okay, and then if you are into the food and beverage industries, also the users, the those who are involved in the preparation of foods, so they need to make sure that all the foods are stored at the required working temperature. Um, Cooling, another example, district cooling, where you use a centralized system, a centralized cooling plant, and you only distribute the chill water using a closed circuit, or the name of it is called the reticulation system. And why it is becoming attractive, because you concentrate everything on a single provider, and then use only for you to distribute the cooling load elsewhere according to the demand. So that's why we have district cooling example. Okay, so ni contoh kalau untuk sistem yang ada cooling dan juga simpanan tenaga haba lah, largest thermal energy storage with the district cooling applications. So it's combination between the refrigeration and also the heat pump process. Another demand for the cooling load is if you're dealing with a data center. Okay. Sesiapa yang involved dalam dunia cryptocurrency, bitcoins, so boleh tengok macam setengah bangunan suddenly ada banyak kompresor air conditioning kat luar bangunan tu. Sebelum masuk dalam bangunan tu ada banyak processing sedang dijalankan. So there are a lot of computer CPUs and everything trying to solve the blockchains, and that's what we call as the apa bahasa dia, bitcoins mining. And mining of those bitcoins require a lot of processing from a lot of CPUs. So you need to cool down the rooms, and usually you're going to use a lot of split units refrigeration system. With the similar demand also, for example, nowadays, especially now we have the incoming PKP lockdown tomorrow, inshallah. So more people will be spending time online, and more will be spending time for those who are mampu, can afford, they will spending more time do the online shopping and so on. So we have what, for example, in Malaysia, we have the Shopee platform, we have the Lazada, or maybe like Lelo and so on. So all these online platform system, they will require a big data center, and the data center must be cooled at the specific working temperature that can not only allow safe storage of all the data involved, but at the same time will ensure they can operate effectively. So there's another example where we going to apply the cooling system for the data center. Mainly composed of electronic devices. So the example I gave you, told you just now, the cryptocurrency industry. Secondly, the online platform, online shopping platform. So the owner of the Shopee, like Lazada and so on, so they need to maintain the data. So they involve a lot of electronic devices, a lot of heat, so they need to cool down the system. So cooling plays key role in the performance of the data center. Okay. And if you don't want actually using the refrigeration system, because you may have this policy, your company have this policy of, or believe that you don't want to dependent on the synthetic refrigerant system because you want to conserve the environment and so on. So you may want to consider natural cooling. So that's what was Microsoft was doing. I think this one is in 2020. It was last year, September 22nd. Microsoft had already invested since 2018. You can see on the article here. Okay, they want Microsoft doesn't want to invest on concept of cooling system like the data center normally people are applying or implementing. So what they decided to do, they take out the data center, they put it underwater. So for 2 years, uh, the depth is around 100 feet and contain a lot of instrumentation and storage value. The Sea of Scotland's Orkney Island in 2018. So they completed the test last year. So they discover the cooling temperature at the bottom of the sea is good enough to ensure the data center operation and sometimes maintain the data integrity and so on. So this is another way of you. So there are two concepts here. You cool down the data center using the refrigeration system, or you use the cooling concept and you use the natural mean to obtain the cooling for your applications. Okay. I just want to share here about the data, the information from Stella. Stella is what you call it, among the leading industrial refrigeration system in USA. So just a browse through on here. So what they have, fast track. So they design and complete the refrigeration system using the modular system, modular concept. Okay, so they have all the necessary equipment. Okay, the frame, the the compressor, condenser, and everything. Okay, and then they design and build it somewhere else, and then once they put it as a modular system, so they ship to the required location, and then they start to connect all the tubes and everything else, and then start the cooling process. So based on their record, they only require 20 weeks from the design until fabrications. So if you are as a mechanical engineer, so you are really keen on designing things, especially relating to the thermal fluids application. So this is the kind of thing that you're going to involve with the design of the vessel, the piping, and so on. Okay, and then you embark on the 3D printing concept here, just to make sure that you get everything, the piping size, the position of the main components are within the required limits and regulations. And then after that, after, for example, in this company, so in entering the 5th week, they start fabricating and then installing all the important components. And then after 20 weeks ni dalam 20 bagi 4, sekitar 5 bulan. Okay, after the 5th month, they can bring the solutions to the customer, start call it, unloading the components and put it in the required locations, and then commissioning it, and then they start the cooling process. Okay, although they have everything as a modular system, but it still require the TS diagram that you discovered in the vapor refrigeration compression cycle. All right, so end of boosting. So at the end of the refrigeration topic. So what I want you to take away today is that we have a household application for the refrigeration, at the same time we have the industrial application for the refrigeration. So both require the same fundamental approach. It's only that maybe you require different physical properties for the components and so on. Okay, next is a request by your colleague just to talk about on the projects. I think most of you already downloaded this thing, and fortunately and unfortunately, because this is also the same topic that the previous semester student had been asked to undertake. Unfortunately, this is also the same topic. So if you're looking for different challenge, then unfortunately it's the same challenge. So is it good or bad? If you, although the topic is the same, so what I want the group to try to deliver this time round is to to provide a different approach on the problems. For example, although the topic here is the design, I think your friend asked, do you need to really fabricate the system? No, you need to provide what you call it design from the thermofluid's perspective. So you need to use your understanding on the thermodynamics and you need to design this solution. Okay, so this is a working the required working parameters. Okay, this is the topic, the task. You already form your team in April last month. You already form your team. So yeah, this one has been done. Next is we have this today. So this is the requirement for the system, 15 to 20 liter per day. Okay, and then this is the kind of refrigerant that you may want to consider. Okay, why do I say may? Because like the industrial refrigerant that I showed you just now, another two important parameters that designer of refrigeration system must consider is the ozone depletion potential as well as the global warming potential parameter. So the selection must reflect the two parameters. You don't want to design something that can actually provide negative implications to the environment. Okay. Number four, provide the report and submit before 30th of June. So for you guys under my class, so the submissions must be through Padlet. Okay, so you need to use the same Padlet that you use to submit your group assignment. So you use that to provide the report on this group project. Okay, so it's purely design assignment. No need for you to construct or fabricate the actual product. Okay, but if you want to gain extra marks, what you can do, you put the background and the motivation for your project is based on what we are facing globally today, the challenge of the pandemic. The issues of the water is quite crucial for countries that have I think the best example just for you is just take the example of what happened in Palestine last 2 weeks. Semua tahu kan isu di Palestine. So why I take that example? Because I just want to highlight the country is next. The country is a coastal line, and due to the heavy bombardment from Israel, what happened is that a lot of the water supply system damaged. Sistem apa pembekalan air macam kalau Johor panggil apa sistem syarikat air Johor, kalau sana maybe syarikat air Gaza ke macam I don't know lah. But among the primary problem that they are facing is the absence of a good water supply system. But they are positioning at the coastal line. So siapa-siapa yang rumah dia kat kalau di kalangan pelajar, rumah dia dekat tepi pantai, boleh tahu kan mana you ada rasa apa, panas dia, bayu malam, bayu siang semua berbeza dan kita ada nilai kelembapan humidity yang kita boleh harvest. So I just want you to choose. Not only you want to solve this group assignment, but put some call it real values in it. Where are you going to put this atmospheric harvester? Is it in Kelantan, Terengganu, or maybe somewhere in Middle East, or somewhere in countries that have challenges of having to secure fresh water? Okay, and then what will be the real demand for it? Okay, like the example that I give to you, but if you take the challenge that people in Palestine is having, especially in Gaza, when they don't have access to clean water. So how many households are in need of the clean water, and how much percentage of your design here can actually supplement and provide the requirement? Okay, if you choose that location as your case study. Next, if you decided to choose somewhere in Malaysia, maybe okay, let's say focus on those that living in the coastal area in Terengganu or Pahang, and then or maybe somewhere in Sarawak or Sabah. Okay, fine. So how many household will benefit from your creation, and then you work backward. So your design not only just to prove the working possibility of your system, but also if somebody take out the design, is it going to work or not? Okay, so ingat yang tu so cari lokasi, tentukan dia punya bakal pengguna, berapa banyak rumah nak pakai, dan buat kajian. The second thing is that in the process of designing these solutions, you need to be as realistic as possible. Apa maksud realistik yang secara realistik? Sekiranya lokasi yang awak buat kajian tu ialah di Malaysia, adakah awak akan invest duit, katakanlah awak diberi sejumlah kewangan untuk laksana projek ni, are you going to invest your money using components that need to be imported from outside Malaysia, or you just want to make sure that major components in this project must be outsourced locally? So bila kita letakkan kita punya syarat dia macam itu, later on you will discover that there are certain things that you can do and can provide, and certain things you are unable to do so because you are depending on the supply from countries outside Malaysia. Kat situ yang nanti datangnya konsep the empowerment of the local industry, menambah baik kekuatan dan kemampuan industri tempatan. So put those two things in mind, the location that you're going to use. Secondly, I don't want you just to pick anything from Google and then okay, use this component and then so on. You need to be realistic. What is the actual component they're going to use, and ask yourself, can I acquire this component in Malaysia, or is it something that need to be purchased from China and then they need to send over, or this something? Because in real life, sometimes when you are working in industries, you may be given between 4 to 6 months to complete the task. Okay, and then once you start doing your design and so on, you suddenly realize that 30% of the main components must be purchased from outside Malaysia. Purchasing items from outside Malaysia will require some times to arrive. First is the regulation of it. Secondly, the issues of payment system and so on, and then the issues of delivery from it. So sometimes it will take 1 to 2 months, 1 ke 2 bulan untuk barang import tiba di Malaysia. So if that is the case, will it affect your promise or outputs to your client or not? Okay, so that is the realism that I want you to put into your design. Okay, and thirdly, do not forget everything has a cost. Setiap satu semua ada benda, ada nilai dia. So what are the costs that are going to be involved? Although you are learning thermodynamics, but you cannot ignore that there are costs that involve in constructing these solutions. Okay, I think it should be enough. They've put it in there. Although the pandemic has become a good friend of the student, where the assessment will become more understanding to the limitation that the student can provide, but please do it properly. No need for you to spend your time copying others. If you really want to learn, then work within your team and really work on providing a valid technological, financial, and legal solutions. Okay, so I think that's all that